I had the good fortune to have him as a colleague in Aberdeen for 6 years. Then he escaped to Amsterdam, and now back in St Andrews as Professor of Logic and Physics. I don't know how many members of the public we have. Anyone here is not a philosopher? Right, okay. Yeah, well, this is one of a series of lectures which Sterling is putting on in connection with our project, Knowledge Beyond Natural Science. It's really just for your benefit. And the broad brief of the project is to look at types of knowledge we seem to have, which impresses in a certain sense unscientific, that is, achieved not by scientific method and difficult to account for scientifically. So knowledge by imagination is squarely in that ballpark. Franz, I think it's fair to say he's widely published, and the centre of gravity of his published work is broadly the philosophy of the absurd. That is, contradiction, paradox, impossibility of various sorts. And going along with that, as you might expect, I think of his philosophy as light-hearted in a certain spirit. Indeed, on his website, he says that he prefers the company of philosophers who don't take themselves too seriously, so bear that in mind for the Q&A. So, great pleasure to have you here, Franz. Thank you. Please tell us about Knowledge Beyond Imagination.
So, thanks a lot for inviting me. Thanks to the Knowledge Beyond Natural Science project. It's great to be here. And I hope I can tell something which is of interest with respect to the purposes of the project, as Crispin said. It's going to be a very informal talk in which I want to introduce to some of the ideas that I'm working on together with a group which has this biggish project called The Logic of Conceivability. And the title of the talk is Knowledge via Imagination, because I want to tell you a story to the effect that this popular idea according to which knowledge and imagination have nothing to do with each other is wrong. People have this view that you imagine something when you don't know anything about it, or that imagination is about thinking of the unreal, whereas knowledge deals with facts, it deals with reality, how the actual world is. But I think there's a certain sense of imagining in which knowledge can be acquired by imagination. And I try to spell out a bunch of conditions that a certain imaginative exercise can satisfy, such that when they are satisfied, you have reliably formed a bunch of beliefs, which can be useful in a number of ways. So that's more or less the plan. So what the hell is imagination? So that's a very ambiguous word. We use it for daydreaming, fantasizing, pretending. Here's the first definition that you find in the Oxford English Dictionary. It says that it's the faculty or action of forming new ideas or images or concepts of external objects not present to the senses. So what is central to the characterization here is that imagining is about representing via images, mental imagery, or concepts certain objects, or I would extend situations, states of affairs, which are not actually there. So in this sense, imagination is escape from actuality. And if that's imagination, it seems that it's very hard to get knowledge by imagination. And people also think that imagination is also opposed to logic. There's this famous motto. It is ascribed to Einstein, but I think it's a hoax. It says, logic will get you from A to B, imagination will take you everywhere, which is supposed to say something positive about imagination, like creative thinking or whatever. But if you're a logician, you can read that as saying something very bad about imagination, because the thought is, well, at least logic, given A, will take you to the proper B's, namely the B's which are logical consequences of the A's you start from. But imagination will take you from any A to any B. So imagining is like a runabout inference ticket. It can take you wherever you like by a free association of ideas. Okay. I think that's also wrong, and that there is in some sense a logic of imagination, and that's actually what I'm working on right now. And I think the starting point to address this issue is to ask a kind of genetic, biological question. So what's the usefulness of imagination? Okay, why is it useful that we imagine? So it seems that human beings can imagine things in a richer and more detailed way than most mammals, if not all of them. But what's the point of such a faculty? So when our ancestors had to fight for food, escape from enemies, survive, they had very concrete problems to tackle, dealing with the actual world. So what's the point of having a faculty of the mind that allows you to escape from reality? And I think that one promising answer is the following. So imagination, at least of a certain kind, helps with planning, thinking of how to achieve a goal or avoid a feared outcome. And in particular, it helps to answer what-if questions. So questions that you ask to yourself when you imagine that something is the case and try to guess what will follow. Now that's a useful thing to do. For instance, suppose that you are one of those ancestors of ours. You're a hunter and you're following a prey, and the prey is on the other side of a stream, of a small river. So should you jump? It may be dangerous to just blindly try. You may get hurt. You may not get to the other side. So what are you going to do? Well, you can imagine jumping. So you ask yourself the question, now if I jump the stream, will I make it to the other side? And if you conduct the exercise of mental simulation properly, I'll try to be a bit more precise on what that means in a few minutes, you may conclude that yes, if you jump, you will make it to the other side. And this will be a new belief that you have formed in a certain very reliable way. That happens all the time. So you're moving to a new house and you got this big couch. Will it fit through the door? Instead of just trying, you try to imagine the situation. You imagine the couch, you imagine the door, and you rotate the couch in your mind, trying to guess if it will fit through the door. And you may conclude that no, it won't, without actually trying. So it's better to disassemble it and move it into the room piece by piece. Okay. So these are familiar exercises. But you can also imagine how very complicated big situations may evolve, like what will happen in case of a disorderly Brexit? That's a very complicated scenario. It's so complex that even experts of politics, economics, whatever, cannot say something precise. But you may want to try and imagine the consequences. You don't want to wait until Brexit comes and find yourself jobless. You try to imagine, okay, what may happen and what you could do if it happens to save your job. Besides, there's a lot of studies in empirical psychology that show that imagination also helps on the know-how side. So skiers who imagine the path that they will follow in the ski run perform better in a downhill race, ceteris paribus, and similarly many other sports. Okay, you may have seen on the television some people who are supposed to go downhill, they are next in line, and they are there with their eyes closed and imagining the trajectories that they're going to follow. Okay, there's a lot of studies that show that that kind of imagination also helps in very practical tasks. Okay, so let's say imagination is a tool to explore possibilities. Williamson has worked a lot on that, and his model epistemology relies a lot on a certain epistemology of imagination. So, taken as mental simulation, imagination is at work in suppositional thinking. So situations in which you suppose A and try to see whether B in some sense follows. And most people agree that some B's follow from the A's that you have supposed, and some B's don't follow. So there must be some logic of imagination, in some broad sense. Now, what is this logic? I think that the logic of imagination is connected to the workings of conditionals. So expressions of the form if A then B. Okay. If I jump the stream, then I will make it to the other side. And it's then a tool to form new beliefs, in particular conditional beliefs. So at the end of the stream simulation, you may reliably have formed the belief, if I jump the stream, I will make it to the other side. So which conditions have to be satisfied for the process to be reliable? Okay, for it to lead you to new knowledge. So first there is a very general issue. How does this view of imagination, according to which at least sometimes an exercise of mental simulation can give you new knowledge, how does that square with the apparently anarchic nature of imagination? The fact that you can imagine whatever you like. So I put here a quote by a very famous Scottish philosopher, and the quote is supposed to give you a feeling of the anarchic nature of imagination. So this philosopher has said, nothing at first view is more unbounded than the thought of man. To form monsters and join incongruous shapes and appearances cause the imagination no more trouble than to conceive the most natural and familiar objects. The thought can in an instant transport us into the most distant regions of the universe, or even beyond the universe, into the unbounded chaos where nature is supposed to lie in total confusion. Now who's this famous Scottish philosopher? Man from Edinburgh, that's David Hume. So how do these two things hang together? Okay, that's a puzzle which has been recently raised. It's called the puzzle of imaginative use. It's at the core of this recent collection of essays edited by Amy Kind and Peter Kung, Knowledge Through Imagination. And the puzzle is, if imagination is arbitrary escape from reality, how can it give knowledge of reality? Okay. If you can imagine whatever you like, how is that leading you to new knowledge? Given input A, it seems one can imagine whatever one likes. How can this give reliable information on whether or not B? So here's an answer. In mental simulation, imagination is constrained. When I imagine jumping the stream to guess if I'll manage, I don't imagine having wings on my back. Of course, I can imagine that too, but that makes the whole exercise pointless. Okay, I don't want to imagine that I jump and that wings take me to the other side. I have this input that starts my exercise of mental simulation. I jump the stream, but then I want to alter reality as I know or believe it to be as little as possible. So I imagine jumping the stream. Okay, that's not actually happening, or not yet. But I want to keep the scenario that I imagine as close as possible to the way that I believe things to be. In particular, beliefs concerning my physical strength, my performance in the past in similar situations, they all matter. I want to stick to those beliefs. So what I look at, roughly, is the most plausible scenario given my previous beliefs and knowledge, where A is the case, and see if B is the case there. Okay. Now at this point, the philosophers among you, that is to say most of you, will start spotting a certain pattern, okay, that has to do with conditional logic and the way in which indicative and counterfactual conditionals are dealt in the mainstream Lewis-Stalnaker treatment. I will be a bit more precise on this soon. Let's say this. So in mental simulation of the kind that I'm targeting, first we start with a certain input, A, and second, we develop the supposition in imagination by importing relevant background knowledge and beliefs. Now, which beliefs, which knowledge are you going to import? Okay, which are, as Lewis said, the cotenable beliefs? That's the really hard question when it's about imagination as mental simulation, I think. So first of all, we do it all the time. For instance, when we read fiction. So you're reading Wuthering Heights, and you read about the last meeting between Heathcliff and Catherine. How is Heathcliff dressed in the meeting? Now you may not imagine in great detail how he's dressed. So imagination underdetermines the imagined scenarios very often. But certainly, you're not going to imagine him as dressed as a NASA astronaut. Okay? You're going to imagine him as dressed as an 18th century country gentleman, even though the text doesn't say that explicitly. The text says a lot of things, but it doesn't tell you, oh, Heathcliff was dressed as usual, blah, blah. Okay? You import that information. The story is temporally located in the 18th century, and we assume, lacking information to the contrary from the text, that Heathcliff is dressed as we know country gentlemen were dressed at the time. So if mental simulation is connected to conditionals, we can expect the fallacies of imaginative thought and reasoning and mental simulation to be connected to the cognitive processes and biases involved in conditional reasoning, suppositional reasoning in general. But here's the first obvious way in which we can go wrong in exercise of mental simulation of the kind that I am targeting. So, situations in which you start by an input, you suppose that A, you develop the supposition in your imagination by importing relevant, co-tenable beliefs and knowledge that you have. You try to stick as close as possible to reality in the imagined scenario, compatibly with the alteration you have to carry out in order to stick to the initial input. Okay, the first way in which you can go wrong is by importing false beliefs. You imagine that Crispin Wright works in Stirling, that's your initial input. You mistakenly believe that Stirling is in West Lothian. You import the belief, and you infer that Crispin works in West Lothian. Okay. The inference is valid, but even though the input is true, it doesn't follow that that Crispin works in West Lothian is true. You just imported a false belief. To get more specific, two main families of fallacies in reasoning have obvious occurrences in imaginative mental simulation of the kind that I'm targeting. Probabilistic fallacies and deductive fallacies. So here's a probabilistic example. It's very famous. So if you study psychology of reasoning, you already know the example. But maybe there's lots of philosophers and there's not a lot of psychologists of reasoning in the whole. So I can try the experiment, hoping that many of you have not been exposed to it already. So now I'm asking, this is the input. I ask you to imagine the following individual as described by a neighbor. Steve is very shy and withdrawn, invariably helpful, but with little interest in people or in the world of reality, a meek and tidy soul. He has a need for order and structure and a passion for detail. Now the question is Steve more likely to be a librarian or a farmer? I ask you to imagine a certain scenario, and I ask you to judge how likely something is in the imagined scenario. Likely. Now, this experiment is very famous, was carried out by Kahneman and other people, because most undergraduates, they do experiments with undergraduates normally, even in Ivy League universities, answer, well, he's going to be a librarian. But that's wrong. It's way more likely that he's a farmer because there are 20 male farmers per male librarian. Okay, that's US data, but I guess it's going to be more or less the same in the UK. So the question doesn't ask you, which stereotype is Steve more similar to? Okay, but that's actually the question that you are answering to when you answer, he's more likely to be a librarian. The question asks you how likely it is that he's a librarian. And it might be that, so many of the people who answer he's a librarian, they are somehow aware, they have in their background bunch of beliefs, the belief that there must be more farmers around than librarians. Okay. Still, when they are asked the question, they think about the fact that Steve fits the stereotype. Okay, so they think by similarity, closeness to a stereotype. They don't think in terms of probabilities. Now, of course, that additional information may rise the probability that Steve is a librarian, okay? But still, there are many more farmers than librarians around. Deductive fallacy involving imagination. So here's an instance of modus ponens. First premise, when it snows, it's cold. Second premise, it snows. Conclusion, it's cold. If you swap the second premise and the conclusion, you got a fallacy, and since you're all philosophers, you know what the fallacy is. So I'm not even going to try to test you on this one. So when it snows, it's cold, therefore it snows. That's affirming the consequent. So it's such a common mistake that we have a name for it. Now, you see that affirming the consequent is invalid by imagining a counterexample. Even basic textbooks of logic ask you to do that. Okay? When they present you an invalid argument, they tell you, oh, you can easily imagine a situation that makes all the premises true but the conclusion false. So you're supposed to imagine a situation where, as in reality, the first premise is true and the second premise is true, but it doesn't snow. So just imagine a sunny, cold winter day. But it's not automatic to see it, and that's why so many people endorse the fallacy. You need to stop and think. It requires a little bit of effort, okay, not to jump to the conclusion. Okay, so there's a general view of why we reason in a fallacious way. It's a view that has been defended by Kahneman, that I mentioned to you before, who makes a distinction between fast and slow thinking. Actually, he didn't invent the distinction. That's due to other psychologists who spoke in terms of system 1 and system 2. People like Stanovich, West. What's the difference between the two systems? So, if I ask you, what's 2 plus 2? That's fast thinking at work. Or if I ask you, what's the capital of France? That's fast thinking at work again. Okay. But if I ask you what's 75 times 12, then you're supposed to stop fast thinking and put system 2 to work. So these are just a couple of examples. The general features of the two systems are as follows. So the fast system is not very good at applying formal rules, logical, deductive, probabilistic, imports biases, intuitions, works by associative memory, free association of ideas, evoked by similarity very often. It's effortless and automatic. System 2 is different. It applies rules, logical rules, mathematical rules, probabilistic rules, performs logical deductions in particular, and unlike System 1, it works by deliberate concentration. And that costs. It has a cognitive cost. Okay. Now, one point that these psychologists have made is that you shouldn't read System 1 as the rational part of you and System 2 as the rational part. We need System 1 most of the time. And System 1 gives the right results most of the time. Okay. You cannot stop and compute in each occasion in life. You go fast. You think by importing beliefs, which includes heuristics and stereotypes. Like, here's a very Humean example. You see a ball rolling towards another ball, and you import your rule of thumb belief. When hit by something, balls at rest begin to move. You quickly imagine what's going to happen. You anticipate. Okay. Small kids are good at doing that. Even before they learn to engage in serious hypothetical, suppositional, counterfactual reasoning, they're very good at anticipating the trajectories of objects in space. But System 1, because it works by similarity, because it's not good at keeping many different things in mind at the same time, also works by, it can lead you to mistakes by importing stereotypes. Paul is French, is gonna like red wine and baguettes. Okay. I think that this kind of distinction can be applied to an account of imagination as mental simulation. In particular, what if questions ask you to work with two mental files simultaneously. On the one hand, you have to keep track of the imagined hypothetical or counterfactual situation, including keeping track of how it evolves. But on the other hand, you have to keep an eye on the actual world, or how you believe the actual world to be, because that is what makes imagination a reality-oriented exercise, which could be of epistemic use. Okay. And there's an amount of work in cognitive psychology by Ruth Byrne and other people who insist on this two mental files metaphor. You have to focus on the situation you're imagining, but you also have to keep track of the actual world and how you believe the actual world to be. Okay. Which makes sense given that sketch that I've given to you before, that imagination as mental simulation is connected to conditional reasoning, where you suppose something and you look at the most plausible scenarios. System 1 is not good at that. Statistical thinking requires thinking about more than one thing at once. And also, fallacies like affirming the consequent have to do with problems with the hypothetical thinking involving conditionals, which is very often correlated with lower levels of intelligence. If it's true that when we evaluate conditionals, so expressions of the form if A then B, we suppose that A, we import into our supposition cotenable beliefs and knowledge, and we try to see whether B will be the case in the imagined situation, then when you evaluate if A then B, then you're supposed to imagine that A and to check whether B would be true in the imagined scenario. There are lots of psychological studies that show that lots of people with lower IQ especially just tend to read conditionals as biconditionals. So they read if A then B as A if and only if B. Or even as a conjunction, actually. So kids do that. So if you throw an if A then B to a very small kid, it's likely that the kid is going to interpret that as an A and B. Now if you read it that way, if you read if A then B as A if and only if B, or A and B, then of course B follows. Of course given A, B follows. Okay. That may be the root of the fact that the fallacy is so widespread. And one can see the fallacy as a mistake of imagination, a mistake in mental simulation. Instead of imagining A and seriously wondering whether, under the supposition B is true, one rushes to imagine a scenario making both A and B true. Okay, so let's see some conclusions wrapping up what I've been saying so far. So first, I tried to argue that imagination is not in general opposed to rational thought, at least when you understand it as mental simulation of the kind that I have sketched. Qua mental simulation, it's essential to planning, thinking about how to achieve a goal or avoid the feared outcome. It helps to answer what-if questions and to anticipate the future. It works by supposing an initial input and developing it to see whether B is the case. It is thus relevantly similar to the cognitive process of evaluating conditionals, if A then B, and it's subject to similar biases. This gives us some hints on how to get better, how to become better mental simulators, given that more imaginative people have advantages qua better mental simulators. In mental simulations, don't jump to the conclusions. Don't believe that given A, B will be the case just because B easily springs to mind or is evoked by associative memory. In probabilistic reasoning, don't generalize from small familiar samples. Don't just imagine, as many people do in Italy right now, because you've seen migrants coming on a boat and sometimes causing havoc, that we are invaded by barbarians. Just look at the statistics. When B would follow from A only by a sequence of independent events, look at probability theory. Think that the joint probability could be small even if individually they are quite likely. So when you're planning whether to open a new restaurant and the number of conditions have to be satisfied for you to be successful, and you think through all of them, you imagine whether you're gonna buy a big place or a small place, how many people you want to hire, to do what, who are going to be your suppliers of food, and so on. And you assign a high probability to each of these things, but you need all or most of them to happen for you to be successful. Okay. It may be that it's very unlikely that all of them or most of them happen. This is very hard to think about. In deductive reasoning, don't endorse an argument just because it's prima facie difficult to imagine the relevant scenarios invalidating it. Look for counterexamples in your mind. So, if imagination as mental simulation is related to the evaluation of conditionals, and if it's true that we evaluate conditionals by supposing the antecedent, developing the supposition in imagination by importing relevant co-tenable beliefs and knowledge, and that exercise, when properly carried out, can give us new reliably formed beliefs, in particular conditional beliefs, then we should look at the many suggestions given by people who distinguish between system 1 and system 2. Because very often it's going to be system 2 at work that saves us from making most of the common mistakes that people most of the mistakes that people commonly make in mental simulation, because they are very close to mistakes in suppositional thinking and in thinking and reasoning with conditionals. Okay, that's what I had to say. I'm just going to quickly mention that that was a very quick and simple and informal presentation for a wide audience, but when things get more difficult, I have a team helping me with that on the project that I mentioned at the beginning. So we have a psychologist of reasoning who works on conditionals. We have a mathematical logician that helps me to develop precise models, epistemic logics for weird attitudes like imagining and conceiving. We have the local epistemologist who works on mainstream epistemology, and he corrects us when we get uselessly technical or too metaphysical, as I tend to. And we have a PhD who works exactly on the epistemic value of imagination. Okay, so that's the teamwork on the project. Okay, that's what I had to say. Thanks a lot for listening to me.